Alright, time for another draftphysics.com, debatephysics.com also. But, as stated, the debate isn't what it should be. That's right, what it could be if, I don't know, people had integrity and character and could actually make an argument. But no. So instead we have this. Oh, it's gone. Oh, damn. All right, so Piro states. So I would compare this to we have an argument to make, and in religion arguments, sometimes you argue things like what a bat is, right? Because the religious kooks say a bat is a bird because God said so, and science types would say no, a bat is a mammal, and it's just happens to be a flying mammal, and yes, they're rare. But they exist, and that's what a bat is. And it's not a bird, and it's not a flying dinosaur. All that kind of crap. And so there's real arguments to be made about the fact that you could say, well, it's body temperature, but that isn't going to help you. Mammary glands and live birth and beaks and no beaks and that kind of thing. And so you have to figure it out that way. Number of toes, all that kind of crap. So you have a real argument. You use real arguments. You argue real circumstances. So that's what I've done in my videos, is argued why I defend the idea that momentum is the elemental function, that there's actually a force that's moving through the universe. Energy moves through the universe as a force. And things collect it, and they can only collect so much, and then they can only give away so much, and it's a real commodity. There's only a certain amount of energy in the universe, and the only way you can do it is you have to give what you got, and you have to collect it, and there's nothing else you can do. There's no special way to make more of it, and you can only collect it. Now, he could counter-argue that, but instead he doesn't. Instead he does this useless crap, talking about how to argue or something, or what's your motivation for arguing. My motivation is the facts the facts I see in the world don't add up to what you're saying is the truth. You're saying 2 + 2 = 3, and I'm saying 2 + 2 = 4. It's that kind of argument. Now you can say you're the ones arguing 2 + 2. Well, then argue the argument, argue the details, argue the experiments. So, and he won't do that. Okay. So he won't do as I'll do, which is draw it and show it. All right. So as you said, my comment was literally true. So I didn't say that. It wasn't an insult or not an insult. The fact that something is insulting to somebody's intelligence is just a fact. Now you can have the impression that you weren't insulting my intelligence by talking about some kind of psychology thing, when the subject is, look at this experiment and how do you describe it? I mean, it's a crime scene and you're detecting who committed the crime, and you're saying that somehow I'm cheating or biased, or I'm not observing the facts correctly, and that you are, and you just veiled that in some sort of psychobabble nonsense, as you always do. You just cheated all over the place. So instead of making a counter argument for why Mr. Mustard did it with a knife, and I'm saying whatever Mrs. Huygens did it with, a pair of scissors. It was an accurate statement of your position. So again, you said it's an accurate statement. It's not an accurate statement because you know nothing about my brain and my life and my existence, and it's just a projection of yours to say that somehow I'm psychologically decided it can't be true when I logically deduced it can't be true. It's a logical deduction. Okay. It's impossible to understand KE because it makes no sense. That's right. It fails to be logically consistent. Okay. 4 pounds dropped 1 foot is not 1 pound dropped 4 feet. Levers prove that's not true. It's not the same energy. You didn't have to be rude, huh? You didn't have to be rude. This is just absolute nonsense. This is why you cannot debate. Well, I'm going to argue that, no, I've made the debates and I've offered money for people to make counter arguments, and the fact is they can't make a good one, and so they don't make a counter argument. So I'm perfectly willing to put on my website the counter arguments to the videos, okay? So I'll place my video up there on a subject like the lever. I've got 10 or 12 different varieties of the video, but the last one will do. And so far, there's no counter argument except some vague notion that somehow the argument's irrelevant, that somehow, even though the lever is demonstrating, the only difference in the lever is the fact that you put a 2 mass on one side and a 1 mass on the other side, and they clearly are equaling each other because of the velocities you've given them. I mean, it's clearly what's happening. Let's see. I didn't name call you. You played a game, okay, of insult the person on the other side by implying a poor intention. So that's what I'm going to do to you. Is just obviously your intention is to evade the argument and distract and create some sort of false impression. Say, make a false accusation and force the other person to defend themselves against it. All right, so I didn't make any false statement or insult you in any way by saying you're a fucking alcoholic and your brain doesn't work right. And that's why you type this kind of drivel, is because you're an alcoholic and your brain doesn't work. So you can't make a logical argument. Just a fact. It's not insulting. All right, I explained your position about understanding any of the theories. So again, you didn't explain anything about why I don't understand the theory. I don't understand it because it's not logically consistent. There's giant pieces of evidence sitting out there that say it can't be what you're saying happened, okay? The Mythbusters crash cars at 50 miles an hour and 100 miles an hour into the same brick wall, and somehow they didn't get 4 times the crushing. So why didn't they? To you, only one is understandable, the true one. Well, the fact is, it's either 2 plus 2 equals 4 or 2 plus 2 equals 3. So, yeah, we're stuck with that reality. It's a fact, okay? It doesn't equal both. You want to believe that. That's maybe part of, again, your alcoholic syndrome, is that you believe 2 completely different statements about the truth, 2 conflicting statements about the truth can be true. So is that what you believe? Do you believe that conflicting statements about the truth can both be true? Why have an emotional reaction to that? It seems you're the one that always has some sort of bullshit reaction. Instead of reacting by explaining why 2 plus 2 equals 4, explain why the Mythbusters car crashes didn't work, explain why levers somehow are lying to us, but instead you type drivel. All right, so fuck you, you're an asshole. So enough of it. I mean, it's just a waste. Like I said, I shouldn't bother letting him comment, because you can't comment relevantly or in any manner that's useful to the conversation. The debate is, how do you prove your statement, okay? Your statement that bats are birds. Your statement that this MV squared thing actually does something in the universe, that somehow it's essential to the function, that somehow they did actually use it to decide how much thrust to apply in landing on the moon. So make the assertion that, yes, of course they used it, because they would have crashed if they didn't use it. The 2 theories get different answers to a simple question. How much thrust do I use? Okay, the 2 theories have a different answer. Okay, so you have to explain why NASA used one instead of the other, or you have to assert that they did use MV squared, and that's why it worked. But you're not doing that. Instead, you're doing this nonsense. Okay. So, fuck you. You're an asshole. A useless asshole. All right. So, I was thinking about it. So, I'll play the spar in a video. Maybe I'll do the drawing first, since it's here. So, I was giving it some thought. Is that right? Those lines are going horizontal. Yeah, that's close enough to right. All right, so some way to at least clear up this conservation of momentum thing, just to make sure everybody knows there's no conservation of momentum in their theory, okay? It's just a fact. So you have the 1 mass and the 3 mass we're doing in this case. All right, so what you do, the first act is you let this, okay, you swing this back and you swing it in, okay. So when you apply it, it has a certain amount of momentum, let's say 100 for the sake of this argument. I could draw bigger than that, actually. This pen's running out already. Okay, anyway. All right, and so what happens, so this is the initial action. The reaction is that the small item swings back, okay, with 50 momentum, and the heavy one swings this way with 150. So the argument is if I stop this one, okay, so now that it's gone to this height, all right, I prevent it from falling. So just pop up on a little ledge there, and so it just waits. Okay, and so this one swings back down again, and it'll come all the way up to it, but won't reach it because it's going a little tiny bit slower, right? They both have the same velocity when they left. That was the trick. This left with the same velocity that this left with. Okay, so they have the same velocity, and this one's starting from a slightly disadvantaged position, so obviously it won't swing all the way over here, okay, if it's allowed to. So anyway, so now you have the circumstance where you have your 150 that you've trapped, okay, your 3 mass, and now the little mass comes right up next to it like that. Okay, so now they're both on this side of the device, and all you do is, let's say you used an electromagnet to lock it in that position, and now you just release it. You just let it fall, and this falls. So now they're both falling in this direction. They're both going in this direction. Okay, this one has 150 momentums. This has 50 momentums. Okay, 150 plus 150 is 200 total momentums moving this way. And then they'll swing back this way, and there'll be 200 momentums going that way. And, of course, they'll decline as it proceeds to go through its function of losing energy, unfortunately, because we can't do the idealization. But clearly, you can't argue it conserves momentum, right? Because now you have a 4 mass, essentially, 4 units of mass, and you have them moving 1/2 the velocity, the initial velocity. So you have a 4 mass moving half the velocity, right? So you have more momentum, not any way to get around it, so there's no conservation of momentum. Let's admit there's no Professor Lewin's full of shit when he says, nature can deal with kinetic energy one way or the other, but nature can't finagle momentum. You're saying clearly nature can. So it's clearly an argument. So to say there's no argument here, that this is some sort of psychological crap, there's a clear argument here. You can't say it conserves. Now you can't do your plus and minus shit anymore, right? And the only thing I changed in the experiment is a nothing event, right? The nothing event is just sticking a block underneath, okay, the pendulum. When it swings to its maximum distance, just stop it. Okay, so it just rests for a little bit, and then I wait to let it fall again. So I just stick a little tiny lever thing, just pops up right at that right distance, boop. All right, holds it. All right, and then I release it when the other one's going the same direction. So clearly I haven't added any energy, haven't changed anything at all. I've just changed the timing of the events. So nothing to violate the experimental rules. Okay, nothing new has been added. All right, it's still a closed system, and your closed system now has 200 momentums in it. So you can't say that you believe in conservation of momentum, and you can't say there's any reason for anyone to believe in conservation of momentum if something this fundamental and this elemental can violate conservation of momentum. Right? No point. All right, so the other thing we don't have is, they love math, but they won't do any. They won't show us their math. So, I haven't bothered because I find the whole thing, I think, it's an obnoxious theory. It's nonsense, so I shouldn't really do it. But the fact is they're making a statement mathematically. Okay, so the 1 mass against the 1 mass, we have 100 in and we get 100 out. All right, I changed this one, make it a little tiny bit heavier, Okay, then I get, let's say, whatever it is, 110, and I get 10. Okay, so whatever extra I get this way, I get the same extra this way. So, we ended up with the circumstance where we're using a 2 mass. Okay, so when it's a 2 mass, let's see if I can draw that somewhere. Well, I'll just put it here, 2 mass. All right, we're supposedly, okay, got 133 going this way. So it's 3/4 of the velocity. Now, see, this may be good to see this experiment. So I don't know if it seems like somebody must have done this in the past, but I guess we don't have a good view of it. But it would be good to see the same kind of video that they show of these other experiments of the 2 mass. They do it with carts, but they don't do it, we don't have an example of it done with a pendulum. Okay, so that would be good to see, right? Because we know this is what the prediction is of their theory, that we have 33% of the momentum goes this way and 133% of the momentum goes that way. So we have 3/4 of the velocity here. All right, so we have 4/4. I mean 2/3. So sorry, my bad. 2/3. All right, and we have obviously 3/3 here. Okay, you could argue. All right, and then when I go to a 3 mass, okay, it does this interesting thing that it isn't integers like this. So I get 50% of the momentum back. That is half the velocity in this light object. Plus I get the 150 in this direction. So this is the experiment we're seeing. Okay, so I have 150% of the momentum. So if we started with 100, we're talking 150 going this way and 50 going that way. So what's the next? What happens here with the 4? Okay, that's the question mark, right? So we have the 4. What happens? Does it jump by, this kind of large percentage of 18, or does it jump by some smaller amount percentage-wise? So, right, there's an 18% difference. There was a 30% difference between the 1 and the 2, right? A 33% difference, and there's only a, so the percent difference is getting smaller. So the 33, so we start with a 33 difference for a 2, and then for the 3 mass, it's only increases by 17, right? So I only got 17, which is half of 33, right? Pretty much, a little less. So it's a little less than half. And so with a 4 mass, we got to figure we're going to get less than half of that increase over the 50. So we gained an extra 50. If I add 17, that would be 60 something. But we're saying it might be less than that. Well, so is it really 66%? No, I don't think it is. So this was 50%, the 17 increase. So maybe it's something less than that. And then 5 maybe is 66, but we don't know. So what's your math predict for those? So it'd just be nice for one of these people who are defending the theory to just give us the explicit answer. What's, it's 33% for a 2 mass. It's 50% for a 3 mass. What is it for a 4? What is it for a 5? What is it for a 6? And then I'm going to argue, it's going to be kind of silly. But anyway, we'll see. When do you get to this maximum where it can't go any faster? So you can't get any more out of it. So does these numbers start going up less and less in terms of how much extra momentum you're making? They must, right? These numbers have to get like very small. So instead of 17% increase, it has to be like a 3% increase or a 5% increase or some smaller percent increase, and you're increasing the mass by a smaller and smaller percentage, right? And when the 2 case, you doubled the mass. In the 3 case, you only added 1/3. In the 4 case, you're only adding 25%. In the 5 case, you're only adding. So you're adding a smaller amount of extra mass. It's not like you're doubling the mass. So you shouldn't have any expectation that you get the same result. So when you double the mass, you get 33%. When you increase the mass by 1/3, you get 17%. So it would make sense that when you increase it by 1/4, that you're only going to get some kind of number like 10% increase. Well, anyway, Okay, so just saying that that'll be the interesting experiment, is the bang it. I can probably do that. I mean, I have some ball bearings that, they don't explain too how they, made the attachments to the metal things anyway. I'm just curious if you can just glue them. I don't really want to weld it, but I guess I could try to with some heavier ball bearings I have. They're all the same size, and I'm thinking of welding them together. Besides, I'm also thinking about, just having one, dangling a hammer, an actual hammer, and having the ball hit the hammer and see what happens. Because we know that's getting close to an infinite weight from the ball's perspective. Anyway, close to an infinite weight. All right, so let's play the Dispar video, and we'll call this a video. So I have to change the thing, so I'll be back. All right, so he titles this, Ian Gosling Didn't Cheat the Experiment. But, if we still don't have Ian confirming the masses, so, whatever. And the fact is whether he cheated or not, it has every appearance that the velocities are wrong. Okay, so there's some frame rate issues that indicate the velocity is only 1/3 the velocity, not 1/2 the velocity. Now, 1/3 the velocity going both directions is still too much velocity. So you still have pretty good indication of free momentum. Now, I say you have the same thing here. So he's showing them both leaving with pretty much the same velocity. So it's not what I would argue would be the expectation. The argument that they're going the same velocity is the argument for a 2-mass, not a 3-mass. All right, so the only little thing, to gripe about is, well, first the only video he gives us is this edited video. Okay, so instead of just showing us the raw video of it moving raw speeds, no, we don't get any of that. Instead, we get this, whatever it is. And, the only thing I notice is these measurements aren't right. Okay, so the distance from this line to this 3 is shorter than the distance from this line to this 3, and they should be the same distance. Okay, they're traveling on the same length, so that should be the same distance, the same center of mass. So those distances should be the same, and they're whatever it is, I don't know, 1/3 of an inch short, that kind of thing. Anyway, all right, and so then the other thing is just looking at it. It just looks, there's something wrong with the way his camera works. So let's understand, this is where he's just releasing it, and it's moving really slowly, right? So it shouldn't have, there shouldn't really be any frame issues, right? Let's see if that works. So far, so bad. I have to click it and then, whoa, that's not what I wanted. Yeah, I didn't want that. I don't know what you got, but I didn't want that. All right, so why did it do that? Anyway, okay, so yeah, it's in slow motion, which is good. But look, just look at the thing. I mean, my arrow works, right? I can point to it. Look at the shape of this. So it's not moving right now. It's going really slow. The slowest velocity it's going to be going is there. This is where it goes really slow. This is where it goes really fast. So this is its slowest velocity, and you're saying, why is that so distorted? I mean, it's not even, it's not even close to being round or, what you would expect. So why is that? Let me see if I can make that part bigger. I mean, really, really distorted. So it's wider than the 3-mass. It's so distorted. So, parallax and all that kind of stuff. This is a really wide angle lens or something, but the numbers aren't distorted. So somehow when numbers are written, they're not distorted, but how come these objects are so distorted? So anyway, I'm just saying, really weird. So, but why? Why did, this is the quality of the video. I'm just saying it's a very slow motion. That's very nice, but I don't get this. Damn, we'll play. All right, Whoops. No, that's not what I wanted. Yeah. God, I hate YouTube. It's such a bitch. Ugh, does this every fucking time. So that's good enough. We can see it. Well, the third trial is interesting of where he cut it off. So that's the one, that's sort of interesting. Because he decided to end the experiment when it was getting a little bit weird and interesting. All right, so here they are coming back. All right, and so you don't see any distortion. Now watch it. Look how it's what? So even at that distance, it's like twice the size. It's twice as big as it was before. And this is when it's going, now it's moving slower as it moves away. So it went from being really small here in the center, and now it's huge. And let's see what else it does. I mean, look at it. It's getting bigger and bigger. Can you see that? I mean, it's just bizarre. Look how huge it is. So what is the artifact? I'm just saying, what is that? Yeah, look at the size of it now. It's bigger than the 3 mass. And nothing else is distorted, though. The background isn't distorted. Nothing else is distorted. Why is the ball so distorted? Do you have an? I don't have an answer. I have no idea how how the hell did he make it do that? It's interesting. It's bizarre. I can't figure that. Hey, how come he's doing it again? Well, anyway, let's watch it again. Look how distorted it is. So it comes down, and when it gets to the center, then all of a sudden it gets round again. So it's completely not round until it gets right about here. Now it starts to look normal. All right. Now the other one, when it's going off, doesn't get all wacky looking. And they don't get as wacky, but the small one still. Look how much it changes its size. So this one did get a little fatter. Okay, the big one does get a little fatter. You can see that still, right? It's in the frame. No, it isn't. Okay, so yeah, it's a little distorted too. All right, so let's just say in my example, we now stop that one from going any further. So it flips over a little. It goes over a little spring device. It just flips it over. And the little thing pops up and now holds it there, right? Okay, and so we're going to keep it there, and then we're going to let the other thing come back. It's going to go right up next to it, and then we release both of them. And now the momentum's going in the same direction, and it's twice as much momentum than we started with. That's their theory anyway. All right, so then they come together. Bang. Now it shoots off, and look at the wacky. Whoa, 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 whoa. Really weird. Sorry, it's just I'm finding it weird that there could be that much of a distortion in the object and nothing else is distorted. None of the other lines appear to be distorted. None of the other objects appear to be distorted. The only thing distorted are those objects moving. And why are they that distorted? That's when it's moving the slowest. So that's the slowest velocity. So why does the slowest velocity look so screwed up? Well, you have to wonder about the frame rates. You have to wonder, did he fuck with the frame rates? He's turned the frame rate so that one is now turned into the same frame rate. The slow movement is the same frame rate as the fast movement. He's altered the frame rates so we don't get to see it moving its natural slow speed. It should be going really slow, but see, he's turned all the motion into motion by distance, not motion by time. And so that's why that frame is so messed up, is because he's altered the frame rates. So you can't measure, it always looks like it's going the same velocity. It doesn't go fast away and then slow down and then go in and go slow. So I can't measure its velocity because he's made all the frames the same speed, right? It doesn't get any faster, right? It just it comes down and it's not going faster and faster. Right? It just stops. Yeah, see, he's taking the speed all out of it. I don't know. Yeah, I can't think. There's still a little there. It seemed to go a little faster up here than it did when it stopped, but I think that's what it is. I think that's what the effect is being created by, is that he's fucked with the frame rates. So the slower it goes, the fatter it gets. The faster it goes, the more normal it is. All right. We'll see. I mean, if that's the case, then we'll have to finally say we'll have certain evidence that Dispar is not worth the time because he's clearly done this on purpose. He's, fucked with it. In a like the regular video, he should just be playing the regular video and show it. He should just upload the raw video footage of it. Just let it go and let it do its thing. So the weird part is, I must just play this through because this gets weird. Now the little one stopped. Did you see that? The little one just stopped, pretty much. That was really weird, right? Okay, so the little one's coming down. Bang! It stops. It didn't go back the way it's supposed to. It just kind of went, I don't feel like it. And now the other one's still moving, but the little one just doesn't do anything. Look, it's wobbling. It's not doing a damn thing. And that's when he cut the video, right? So this is what it looks like when he's, showing it. How come it looks so nice and clean and it's light and you can see things? And why is it so much brighter and clear? And then the video he shows us is dull and shittier, frankly. Why? Why the difference? All right. So anyway, just saying. Okay, but whatever. It doesn't matter. I mean, I'm just saying. Look, if this is the truth, if it's true that they're going the same velocity, yeah, the argument is kind of over. But you can't conserve momentum if they're going the same velocity. Okay, I don't think so. And then the key thing will be to see the 2 and the 4. So the 2 mass, compare the 2 mass to the 3 mass to the 4 mass, and then you can see the pattern. All right. But from this one clip, I'm still saying. And so Ian Gosling hasn't made a follow-up video saying, well, here, I have really confirmed the masses, and this is how I confirmed them. So he still hasn't done that. And again, frame rates here aren't going to do you any good because these frame rates appear, okay, when you do the frame rates on this video, it appears as if it's half the velocity. But the argument is maybe that's why this distortion exists, is because the frame rates are lying to you. He distorted the frame rates. All right. Seems a logical possibility, right? Yeah, it's a possibility. Did I close that window? I guess I did, because it's gone, right? Well, you could see it before, right? I believe you could, right? If I do that, yeah, it shows. Okay. Yeah, weird. Didn't know I could do it that way. So anyway, all right, so we'll call it a video. But really, come on, real arguments, okay? So I did the lever argument. I made the point about the angular motion. It's about velocities. It's not about distance. It's about how much velocity you have to give an object when you're moving the two things. So the 2 mass is moving half the velocity of a 1 mass, 2 units of distance. And there's just no doubt that those two things, by nature says those two things are the same thing. A half mass moving twice the velocity is the same energy as the full mass moving 1 velocity. The 2 mass moving half the velocity is the same as the 1 mass moving 1 velocity. Okay. 2 velocities. Jesus. All right. Anyway. Yeah, enough of it. Yeah, that's just very strange. I really can't. So I'm just saying, when you're looking at that Ian Gosling video, I'm just saying you have to concede, right? I mean, is there anything else we can blame that on? That huge, gigantic distortion. All right. I mean, it's just so glaringly big. I mean, it's just, whoa. It gets huge, and nothing else is distorted. So I'm just saying the 3 and the 12 and the little numbers, these lines aren't all bent out of shape. The shadow lines are in the right place. I think there's some underlying lines on the paper here or there. The edge of the paper isn't, it's a little canted. It's a little, look, this little creak in the paper isn't distorted. So something else distorted the video. It can't be parallax. It can't be some other thing. It can't be the camera's a wide angle camera and it's destroying the view because it's destroying everything that goes out, because then the lines would be curved like the baseline there. the line that's the flat surface. That flat surface line would have also canted if it was a wide angle lens that was causing it. So it has to be that he's disguised the frame rates. He's made the slow things, he's forced them to be the same size frame as the fast moving, and that's why it's gotten so big when it's moving slow, and it gets small when it's moving fast. Oh, so really, if it's true that's what he did here, you have to admit that that's shenanigans, right? That's not an accident anymore. That's not his ignorance. That he looked at the video, saw that the video wasn't showing the right velocity, half the speed, twice the speed, and he forced it to look like it's half the speed. He forced it. Or there's some other reason. I'm just saying, I can't, I'm looking at it. I'm just saying, why is that ball now as big as the 3 mass, right? It's now as big as, right? You can see that, right? This is as big as this. How did it do that? It's further away, technically. It should be getting smaller, not bigger. Why is it bigger? All right. It just doesn't make any sense, is what I'm saying, right? So this is their argument. They're saying a bat is a bird, and it looks a little bit like they have glued some feathers on the bat's head. Okay, that this is a little bit cheaty. Okay, that's how it looks to me. Now maybe you have an explanation. Maybe one of the little trolls can come up with an explanation and explain how the fuck that thing got 3 times its size. How did it get so goddamn big when it's further away from the camera? It's further away from the camera now. How did it get so goddamn big? All right. So anyway. Yeah, I don't know. So, I mean, look, I guess this will sort of be the telling story, right? You'll have to concede, right? If this is true that he deliberately gave us this crappy video instead of showing us the actual video, you'll have to concede that, yes, they're just about the shenanigans. They're not about the truth. All right, so enough said. Bizarre, though. I don't get, I don't even know how to do that in my video editor. I don't think I could do that in my video editor. I'd have to figure out how to do it. I don't know how to do that. How do I make this get bigger as it moves further away without changing any of the other objects without making the 12 huge, without making the numbers get bigger and bigger? Make this line get fatter and fatter. It is a little bit fatter. Well, it's not fatter over here though. No. So you can't use that argument. Nothing else is fatter in the image. Do you get my point? How can the ball be 3 times the size and nothing else is distorted? Not even the strings. How can you do that? All right. So Piro, this is no reason to be suspicious, right? Somebody shouldn't be suspicious. If they showed up at the science conference and this is the video they showed, no one should raise any eyebrows and say, "Oh, that doesn't look right. There's something wrong with that picture there. That object is bigger than it should be, isn't it? I mean, it's bigger now than the other marble. How does it get bigger?" Oh, okay, and then he switches to trial 3. All right, so enough, right? Enough. Yeah, we've had enough of this shit. It's not 3 times bigger when he lets it go, right? Okay, so that's something else to notice. I mean, it is interesting, right? It's not 3 times bigger here, when he lets it go. So it's only in the second. We got to wait for the second bounce. Well, now it gets big, but it's not. Obviously, it's not 3 times bigger. Let's see. This one's the one where it really gets big. All right, well, it didn't grow this way as much, right? So you can say in the third trial, somehow it didn't get as big. Why? So now you have to even understand, well, why is it before it was 3 times this. You know, it was as big as this. It was even bigger than the 3 mass, right? It was bigger than the 3 mass before. How come it's not bigger than the 3 mass in this video? And look at the shape of it this time. It didn't really get long. You know, it didn't stay round. It's only longer in one dimension. So I wonder what he did different in those 2 trials. All right, anyway, so there's no point in trying to figure it out, right? Well, there is a point in trying to figure it out. It is curious. How the fuck do you cause that effect? How do you make something that's further away from the camera look bigger? That's an interesting physics question, isn't it? I think it's fucking interesting. Yeah, I don't know. I've never seen a camera do that. I've never seen a camera where you're further from the center, right? So the further I go over here, the further away my finger is, the smaller my finger would get because it's further away. It gets smaller because the line is longer. The photons have to travel more distance. Inverse square law. And yet it's bigger. Anyway. All right, I'll quit just wondering. But, you know, it really is irritating. They forced me to do this Columbo thing, you know. See how we fucked it up. Okay, yeah, I'm going to try to fool you. Here we go again. It's another one of these fake experiments I'm going to do where you have to figure out, how did I fuck it up? How did I cheat? How did I screw with this? Shit. Damn it. Anyway, enough of a video. It's just be nice to get this done and over with, right? Get all of these experiments done right and well that don't have this weirdness in them, okay? And let's just prove the point. Let's see the 2 mass, the 3 mass, the 4 mass, and the hammer. And let's see what the results are. And figure out if it's 2 plus 2 equals 4 or 2 plus 2 equals 3. Let's find out the truth instead of this shit.